Can I go? Okay, that's a yes.
Yeah.
Right. You can also manipulate first the cosine rule, right? So the cosine rule is a squared equals b squared plus c squared minus 2bc cos a, right? That's the way it's written in the log tables, right? If you bring the 2bc cos a over, so just here at the side I'm going, 2bc, if I bring that over, 2bc cos a, so I'm bringing that over to the left, right, equals b squared plus c squared minus a squared. Okay, so I brought that over to the left and I brought the a squared to the right. Okay, and then you divide across by 2bc, so you get cos a is all that. Okay, so you can manipulate that. Now you can also change that to cos b, right? If that's cos b, these are a and c, and that's a b, right? You can change it to a cos c, so that would be a, b, and that would be a c, right? Okay, so just know you can manipulate it, right? It's written this way in the log tables, but remember we're able to write it differently with the different letters if we need to, right? So identities involving the sides, so small a, small b plus small c, generally require the use of the sine rule or the cosine rule to prove them. Okay, so okay, ready? No, still writing. Right, ready? So example 1.
Yeah.
Right, okay, so example 1 just has that written down. Prove b cos c plus c cos b equals a. Right, if you look at this, girls, you want to turn it into a single letter on its own. So that means you have to get rid of that cos c and you have to get rid of that cos b. Right, okay, so the clue is in the answer, okay, as in you have to get rid of those because you want to turn all of this into A. So you need to get rid of them. So the only way to get rid of them is to use the sine rule. Okay, so the sine rule, if you look here, go back here, so instead of cos, now it's cos C. So instead of cos C, that would be a C, these would be A and B. So it's, instead of cos C, it's A squared plus B squared minus C squared all over 2AB. Okay? And then instead of cos B, right, okay, it's, instead of cos B, that would be a B, and these would be A and C. So it's A squared plus C squared minus B squared all over 2AC. Does everyone see where I came up with these? Okay, so you're not going to remember these, you just need to take the cosine rule from the log tables and manipulate it yourself over to the side. Okay, because you wouldn't be expect anyone to remember those. Okay, so then when you've that done, multiply into the brackets. So the B will go with the B and the C will go with the C. Okay, so here I've ended up with A squared plus B squared minus C squared all over 2A. Then I have A squared plus C squared minus B squared all over 2A. Right, they're both over 2A, so I'll just put them big long line. So I have A squared plus B squared minus C squared. Then I have plus A squared plus C squared minus B squared. Okay, so minus C squared plus C squared will go.
Miss, why do you have two kind of different things in the brackets?
Because this one was cos C and this one was cos B. So I manipulated the formula for cos A. So just know, right, when it's cos A, it was BCA and BC. Right, so if it's cos B, it's AC, A and C, the only B is here, right, all over 2AC, all over the two ones. And the other one was, that was cos B, and cos C means I have AB take away C all over A, 2AB. Okay, it's just because these letters were different. Is that right? Okay.
Yeah.
Multiplying in, right, okay, getting a common denominator, they're already over the same thing. Right, okay, so when minus C squared plus C squared will go, plus B squared minus B squared will go. So on top I'm left with 2A squared, and on the bottom I'm left with 2A. So the 2's will cancel, right, and A squared divided by A is just A, and that's what I got over there. Okay? So the trick is, if you see the small A's, B's and C's, they represent the lengths of the sides, and the only way to get those in is to use either the cosine rule or the sine rule. And it's obviously the cosine rule here, right? Okay, example 2 will obviously be the sine rule when you see it. Is that right? Can I take that away? Right. Example 2 is next. Right. So it's sine A minus sine B over sine B and turn it into A minus B over B. Right. Okay. This is sine A. This is sine B. This is sine B. Okay. Now, there's no point in changing them all because from the sine rule, remember sine A over A, sorry, you write it the other way, it's the same thing though. A over sine A equals B over sine B. Remember, that's your sine rule. Okay? So, this is A, this is B, this is B. So what am I best to? I'm best to change sine A into sine B, aren't I? And then they'll all be the same. Because if I decide to change sine B, I have to change two of them. Right? So I'm going to rearrange that so I have B sine A equals A sine B, and then divide. So sine A equals A sine B over B. Okay, so that's what I'm going to use. Instead of sine A, I'm going to write in A sine B over B. A sine B over B. So it's a minus sine B all over sine B. Now, this term has a fraction, so I need to get rid of that. So in order to get rid of that, I multiply everything by the common denominator. So the common denominator is B, isn't it? So I'm going to multiply each term by B. So B multiplied by that term minus B multiplied by sine B, and underneath the line multiplied by B. So if you multiply everything by B, you haven't changed it. Sorry. Okay. So on top, I have A sine B minus B sine B, and on the bottom I have B sine B. So on the top, just give me a second, I'll move that out of the way. Sorry, no, I'm back. I'm not. Don't mind me. Oh, Jesus. Please go away. How do I get rid of that? Oh, Jesus. Sorry, girls, I don't know what I'm doing here. I'm just, yeah. There we go. And I just wanted to move that out of the way, was all I wanted to do. Right, okay, so here on top there's a sine B common to everything. So take a sine B out of on top. So sine B out, and you're left with an A minus B inside the bracket. Below I have B sine B. Then the sine B and the sine B can cancel, so I'm left with A minus B over B, which is what they asked me to turn it into, so I'm right. Okay? Is that alright? So for tonight, I'm going to ask you to do page, I'm doing lots more now, but this is just the first part of your homework. 20, 22 and 24. So page 307, 20, 22 and 24, that's just the start of the homework. I'm moving on. I have so much to get through today. I'm getting through a load of work today, and then okay, right. Okay, I'm moving on to the next section, which is compound angles, right? I know I said I'd leave you off for a while and bring you back again, but I changed my mind because I have so much work to get through. Right, can I rub this out? I'll take that, yeah? Okay. Because I need the boards. Okay, we're going back to some of our mandatory proofs, stuff that you will just be kind of asked straight from the book, okay? So, and as I say at the end, I'll give you a list of everything, of all the proofs that you need to know, okay? But if you look at your log tables, right, on page 14, on page 14, girls, there's a load of compound angle formulas. See these? Right, double angle formula there for later in the week. Compound angle formula, right, okay, you have to be able to prove all of these, right, okay. So there's 1, 2, 3, 4, 5, 6, there's 6 formulas. You need to be able to prove all 6 of them, okay. There's hard work in one of them, right. The first one we're going to prove is this one here. There's hard work in this one, and after that it's just manipulating them a small bit, okay. So I'm going to do 4 today, okay. So the first one is pretty long, right, but the others are a bit shorter after that, okay. So that's what I'm doing for the rest of the day, okay. Not the rest of the day, the rest of the class right, okay, right. So the first thing I'm going to do is compound angles. So I'm going to prove cos of A minus B to prove cos of A minus B is equal to cos A cos B minus sin A sin B. Okay? So it's in the log tables, right? The formula, you just need to be able to prove it. Okay? So we prove it again using our unit circle. Okay? So I might rub this out and start again. So unit circle. Okay? So I'm going to do an angle here, right? So from there to there, that's called angle A. Is that right? Okay. So I'm putting an angle in the second quadrant, right? And I'm calling it angle A. So remember, the angle is all the way back to the first quadrant. Is that alright? Remember, this is unit circle, so the length of that line there is 1. Okay, because it's a unit circle. And the coordinates here would be cos A sin A. So it's the cos of that angle, the sine of that angle. They're your coordinates. Okay, is that right? So then I'm going to do another line in the first quadrant, right? Now I left my coloured pens at school, which is a bit awkward, but anyway, sorry. Angle A is the big angle, right? Here, from here to here is angle B. Okay? So that means that line there also measures 1 because it's radii and it's unit circle. The coordinates here are cos B, sin B. Okay? And then the angle in the middle, I wish I coloured pens now, but the angle in the middle is A, because A is the whole way, take away B. A is the big angle all the way back, B is this bit here, so the angle here between the two lines is A minus B. Is that okay? Now, and I call that point O, and I call that point P, and I call that point Q. Now, and your proof is to find the length of PQ, so the length of the line from P to Q. So the line from P to Q goes across here. So I'm finding the length of that line in 2 ways. So I'm going to do 2 things to find the length of that line. Okay? So from P to Q. Right? Okay? So first way is use the distance formula. So I have, square root of x2 minus x1 to be squared plus y2 minus y1 to be squared, right? Okay, and hang on a second, I'm just checking something. Right, we have to do cos A sin A, okay, and we have cos B and sin B as our 2 points, yes, okay, so I'll call this one x1, I'll call this x1, y1, and I'll call this x2, y2.
Miss, how do you know that they're your points?
Because it's the unit circle, right, okay, so, and I'm getting the distance from here to here, and every point on the unit circle is cos sine of whatever angle it makes with the positive x-axis. That's the rule of the unit circle, okay, so, yeah, so then I fill in, so it's cos A minus cos B to be squared plus, what's it, y2 sin A minus sin B to be squared. Can I move this up like this? Okay, then I'm going to, so this is the length of the line PQ. So the length of the line from P to Q, girls, is using the distance formula, coordinate geometry of the line, right? I'm going to square out, right? So here, square the first term, twice the first by the second, which would be 2 cos A cos B, square the last term, which would be cos squared B. Right, I'm going to square out this bracket. Square the first term would be sin squared A, twice the first by the second, which would be minus 2 sin A sin B, and then square the last term, which would be sin squared B. Sorry, a bit squashed there. That reads sin squared B. Okay. Right, cos squared A plus sin squared A. Does anyone know cos squared A plus sin squared A? What will they give me? 1, won't they? So cos squared A plus sin squared A will give me 1. Cos squared B plus sin squared B will also give me 1, won't it? Okay. So then I'm left with minus 2 cos A cos B and minus 2 sin A sin B. Okay, so I've got rid of the square terms because cos squared A sin squared A will give me 1, cos squared B plus sin squared B will also give me 1. So I've got rid of the square terms, but I still have these big long things here, right? Now that's P, that's the length of PQ, right? I want to get rid of that square root sign, so I'm going to get PQ to be, I'm going to square both sides. PQ to be squared is equal to squaring this side. I just get rid of the square root sign. I just tidy it up. 2 minus 2 cos A cos B minus 2 sin A sin B. Okay, and I want to park that there for a minute. Okay, so remember I was saying I was going to get the distance in 2 different ways. That's my answer to the first way. Okay, so that's my answer to the first way. Is that right? So I just use the distance formula between the 2 points, cos A cos B, or cos A sin B, cos A sin A, cos B sin B. Okay, right. Now that was the first way. Right, back to my original diagram. Okay, so I'm going to just see there's a triangle in there. See there's a triangle in there. So the second way, I'm going to use the cosine rule. Right, and I'm just going to draw out that triangle there. So this is O, this is P, this is Q, right, and this is the angle A minus B. Okay, is that alright? So A squared equals B squared plus C squared minus 2BC cos A. Okay, so that would mean that I'm going to call PQ, so A, so PQ to be squared is equal to the other two sides, OP to be squared plus OQ to be squared minus 2 times OP times OQ cos of this angle, which is A minus B. Okay, so I've just used the cosine rule, right? So PQ to be squared is what I'm looking for. I'm looking for the length of this line, right? Now, OP, guys, this line was a radii in the circle. So if you go back to the circle, that's a radii. So that measures 1. OQ squared also measures 1 to be squared, right? Sorry, that should be a minus sign. Minus 2 times OP, that's a radius. OQ is a radius times cos of A minus B is the angle in the middle. Okay? Sorting that out, you get PQ squared equals 1 squared plus 1 squared is 2 minus 2 cos A minus B. So there's my second expression for PQ to be squared for the length of that line. Okay? So I might call this result 2. And I'll go back and I'll put this back in 1 minute. I'm just going to put result 1 there. Okay, so if you look, guys, result 1 told me PQ squared was equal to all of this, right? Result 2 told me that that was a minus, was it? It was, yeah. Yeah. Result 2 told me all of this, okay? So what do you think I'm going to do? I'm going to let, this one is PQ squared is all of this. This one is PQ squared is equal to all this. So if I take the answer from result 1, which is 2 cos A cos B minus 2 sine A sine B, that's what I got from result 1. So if I let that, cos that's PQ squared, the answer from result 2 is also PQ squared. So I'm going to let it equal to the answer I got from result 2. Okay, so there's the equation I end up with. Okay, the 2 and the 2, when I bring one of them over, they'll cancel. 1 will become a minus 2 will give me 0. Is that alright? I'm going to bring this over to this side. So it was minus 2 cos AB, now it's plus 2 cos A minus B. Right? And I'm going to bring the others over this side. So that becomes 2 cos A cos B. And then that would be plus 2 sine A sine B. Okay, divide everything by 2, you get cos of A minus B equals cos A cos B plus sine A sine B. And that's what we were trying to prove, and that's your answer. Okay? Have you all lost the will to live? Pretty much. Yeah. It's okay, right? As in when you look at it first, it's crazy, right? I'm sure you've just a page of crazy crap there. But when you think about it, and I'm just going to go back and explain it again without writing everything out. Okay? So when you've finished writing, you can listen to me for a minute. Actually, I wonder. Oh. Okay, are you ready? I'm just going to explain it again. I'm not going to write it out. Okay? Right. So the first thing, unit circle. Right? So remember, unit circle, every point is cos sine, cos of the angle it makes with the positive sense of the x-axis. So I made an angle in here. So the whole angle all the way back to the positive x-axis is called A. Right? So that means this point on the unit circle is cos A sine A. Right? And this is a radius. It goes from the center to the edge of the circle, so that line there measures 1. Okay? Then I made another angle here. So the angle here, girls, from here to here is angle B. So that means this point here is cos B sine B. Right, this line here also measures 1 because it goes from the center to the edge of the circle. And the angle in the middle, so the whole big angle was A, this little angle is here, so the angle in the middle there is A take away B. Okay, is that right? So then you join the points, join that to that, and you're going to get the length of that line in 2 ways. So one way you're going to get the length of that line is to use the distance formula and square it out. Okay, so that's what we did first. The first way was we used the distance formula and squared it out. Okay, and tidied it up. Remembering that cos squared A plus sine squared A gives me 1. Cos squared B plus sine squared B will also give me 1. Okay, then what I did was I took that triangle there in the middle. This is A minus B. This is 1. This is 1. Because that's radii, that's the angle in the middle, and I used the cosine rule to find the length of this line, so I called it PQ. So I used the cosine rule to find the length of that line. So then I took my answer from part 1 and I let it equal to my answer from part 2, and I just manipulated it and moved it around, and I ended up with my result, which is up here. Okay, so that's the hardest proof. Okay, and the longest proof. Okay, so can I keep going? I'll take that as a yes. Or you're all dead either. Either way, I'm keeping going. Right, okay. Before I move on, girls, right, don't write this down. Now, this is me just explaining something to you. Right, the first thing is, right, in the log tables for our further proofs, we're going to be using this. You see these here, it's on the first page of trigonometry. You see these values here, right? So cos of a negative angle is equal to the cos of a positive angle, right? So cos of a negative angle is equal to the cos of the positive angle. That just means if you get the cos of 30 and you get the cos of minus 30, you get the exact same answer. If you get the cos of 70 and you get the cos of minus 70, you'll get the exact same answer. Okay? Right? That's the first thing. If you were to get the sine of a negative angle, right, it's equal to minus the sine of the angle. Okay? So the sine of 30 and sine of minus 30 will have the exact same value, but they'll have opposite signs. That's all that means. Okay? So cos of a negative angle and cos of the corresponding positive angle will have the exact same, right, sines, values, etc. Sine of an angle and sine of a negative angle will have the same value but opposite signs. That's what that means. Okay? That's in the log tables. We're going to be using those in a minute. Right? You needn't write them down. They're in the log tables. Okay? Right? The second thing before we go forward, girls, is if you take a right angle triangle, okay, and I call this A. So would you agree that up here, this angle here would be 90 take away A? Because if that's 90, these two add up to 90, so that angle up there would be 90 minus A. Would you agree? Okay, so if I call this X, Y, and H, okay, so I'm going to get the sine of A. The sine of A equals O over H. Would you agree? Oh, sorry, what am I saying? Opposite over hypotenuse, which is X over H. Agreed? Okay, opposite X over hypotenuse. Right? If I was to get the cos of the other angle, 90 minus A, so I want to get the cos of this angle, right, which is X over H. Right? Same answer, isn't it? So that means that the cos of 90 minus A, don't write this down now, you don't need to. It's just a fact that I'm just explaining, but you can just accept it as a fact. So that what that means is, girls, that the sine of 30 is the same as cos of 60. That the sine of 70 is the same as cos of 20. Right? That the sine of 50 is the same as cos of 40, right? Okay, so, and you can check it out in your calculator, you get the exact same numerical values. So cos of 90 minus A is sine of A, right? Is that okay? And you can also prove that the cos of A is equal to the sine of 90 minus A. So they have the same numerical value, right? Is that okay? Right, so you'll need these going forward. So going forward, right, to prove the rest of them, right, we need this, and we also need that the cos of 90 take away A is equal to the sine of the angle. So cos of 70 will be sine of 20, right? And we need to know that the sine of 90 minus A is equal to the cos of A. Okay? So they're just important facts going forward. I'm going to use them to prove other stuff. Okay? As I say, this one up here was a hard proof, right? Okay? And this is going to be our starting point for the rest of the proofs. Okay? Because we proved this, we now accept this as fact, right? Okay, so cos of A minus B is cos A cos B plus sin A plus sin B. Okay, so on the log tables, I proved this one up here in the right hand corner. I'm going to use that, so that's the one you prove, right? Okay, you use that then to prove all the rest of them. I'm going to do 3 more today, that's it, then I'll leave you alone after that. Okay, right, so, I get a blank board, I've written on them all, here I have, right, so I'm now going to prove that cos of A plus B, sorry, cos of A minus B, I just did A plus B, no I didn't, I just did A minus B, sorry, cos of A plus B equals cos A minus sine A sine B. Okay, so this is a plus, it was a minus. This was a plus, now it's a minus. Okay, is that alright? So your proof, you always start a proof off with a true statement. So the true statement is the one we just proved. So we just proved that cos of A minus B equals cos A cos B plus sine A sine B. Okay, so we've just proved that this is a fact, right? Okay, and all you have to do is replace B with a minus B. So everywhere I see a B in this formula, I'm going to put a minus B, because this formula holds true for every single angle. So it doesn't matter which angle you pick, it's going to hold true for every single angle, right? So I'm just changing the angle. So instead of putting in a positive B, I'm going to put in a negative B, right? So that means that cos of A minus B is equal to cos A cos of minus B plus sine A sine of minus B. Okay, so that would be cos of A minus B is cos plus B. Here we have cos A, right, and I know, right, because I've just told you, but it's also written in the log tables, that cos of a negative angle is the same as cos of the positive angle, right? So I know that cos of minus B is the exact same as cos of B, right? Then I have plus sine A. Now here, sine of a negative angle is equal to minus sine of the angle, right? So instead of getting sine of minus 70, I could just get sine of 70 and put a minus in front of it. So that's minus sine B, so it's multiplied by. Okay, so that means cos of A plus B equals cos A cos B plus by minus is a minus sine A sine B. So that's the second one proved. So the first two across the top proved. Okay, right. Okay, right, I have two more to do. I know I'm killing you, but can I take this away?
Yeah.
Yeah, so the next one I'm going to do is the second one down. Okay, so it's to prove sine of A plus B equals sine A cos B plus cos A sine B. So again, it's the second formula down. Okay, so proof, again guys, we start off with the only one we have proved, right? The one that we proved with the big long proof. So this is our starting point for everything now. So I know that, well, I could start with the last one too, couldn't I? Yeah. cos of A minus B equals cos A cos B plus sin A sin B. Right? So to prove this one, girls, you replace, this holds true for any angle, so that means you should be able to put in any value. So you replace A with 90 minus A. So everywhere you see an A, you're going to put in a 90 minus A. Okay? So this is cos of, instead of that A, I'm going to write 90 minus A, and then there's a minus B. Okay? So that would be equal to cos of, I'm replacing A with 90 minus A, B stays the same, I'm replacing A with 90 minus A, so that's in sine of 90 minus A, and then sine B stays the same, so that's sine of B. Okay? So this is the same as, what is that? Oh yeah, sorry, I'm looking at the, this is just the same as, just take the minus outside the bracket. So that's 90 minus A plus B, is that alright? Okay, over here, cos of 90 minus A is the same as sine of A. Right? Then leave cos B as it is. Sine of 90 minus A is same as cos of A. And sine B stays as it is. And then cos of 90 minus A minus B is the same as sine of, A plus B. So sine of A plus B equals sine A cos B plus cos A sine B. Okay, and that's that one proved. Right, okay, and to prove the last one, I'm just going to continue, so that's a proof. Right, once you get that far, replace B with minus B. Okay, so I just proved which one, that one. I'm now going to finish it off with this one, and then I'm done. You'll be happy to know. For today, it's pretty crazy, these, but so everywhere I see a B, right, I'm going to replace it with a minus B. So that's sine of A plus minus B equals sine of A cos of minus B plus cos of A sine of minus B. Okay, that becomes the sine of A minus B equals sine of A, and we know that the cos of a negative angle is the same as the cos of a positive angle, right? We know that cos A is the same, sine of minus B is the same as minus sine of the angle. So the sign in front changed to a minus, okay? And that's that proved then. Okay? Right, I proved the 4 at the top. Okay, that's enough.
Yes, could you explain the last one again?
This one?
Don't mind. Yeah, the one you just did.
Just here. Right, so I took the results that I proved there, and everywhere I saw B, I put in a minus B. Right? So instead of that being minus b, instead of that being minus b, instead of that being minus b, right? This became plus minus b is a minus b, right? This, a cos of a negative angle is the exact same as the cos of the positive angle, right? And the sine of a negative angle is just the sine of the positive angle with a minus in front of it. Okay?
Yes.
Is that right? Okay?
Yes.
So, just one example, right? Okay, just so you know what kind of questions they ask, right? Okay, so what they might ask you is, and then I'll leave you alone after this because I've been talking for 50 minutes, you must be sick of me. Example 1, right? Express in third form. So that means, now you could just type it into your calculator, but they want to see the work. So, or they say use the compound angle to go cos of 15 degrees. Okay, now you could just type it into a calculator and press equals, but they want to see you using the compound angle formula. Okay, so what we do is, right, for these, where did I put my log tables? Go back to page 13 on your log tables. Okay, so page 13 on the log tables, I'll just blow this up a minute, right? Okay, see the way we have insert form in this table, we have 90, we have 30, 45 and 60. So you express your angle as either a sum or a difference of 90, 45 and 60, right? Okay, so the first one is 15 degrees. I'm going to say that's the same as the cos of 45 take away 30. Okay, so that's the same as cos of 45 take away 30. You could also say it's 60 take away 45, you'll get the exact same answer, right? Okay, there's more than one way sometimes, okay, but I'm going to say it's cos of 45 minus 30. Okay, so that's the cos of A minus B. So off I go and get my cos of A minus B formula. Cos of A minus B formula was cos A cos B plus sin A sin B. So everywhere I see an A, I'm putting in a 45. Everywhere I see a B, I'm putting in a 30. So that would be the cos of 45 minus 30 would be the cos of 45 times the cos of 30 plus sine of 45 times the sine of 30. So that's cos of 15 equals, off to that table on your log tables, so you get the cos of 45. So the cos of 45 is 1 over root 2. Multiplied by the cos of 30. The cos of 30 is is root 3 over 2. Then there's a plus sign. Sine of 45 from this table, sine of 45 is 1 over root 2. And the sine of 30 is root 3 over 2. Okay? So then, multiplying that out, that's the cos of 15 equals, multiply top, root 3 over 2 root 2.
Because it's not a half.
Sorry? It's not a half?
It's sine of 30, not a half.
But it's sine of 30, not a half. I probably read it wrong, it probably is. Sine of 30 is a half, sorry. Apologies. Right, okay. Right, plus 1 all over 2 root 2. Right, and that would be 2 root 2 root 3 plus 1. Is that right? That's your answer in third form. Right? You can simplify that another bit, but you don't have to. It's just if you type it into the calculator, they'll just give you a different thing, but it'll be the exact same thing in a different form. But that's sufficient. That's in third form. That's what they ask for. Okay. So there's questions like that. Okay. So I know you can't listen to me for any more. So I'm going to ask you. I've given you 3 questions already, right? I'm going to ask you to do page 311. Just do question 2 for me, right? Okay, and look over all those proofs that we just did, okay? Because I could talk for 5 hours, but until you look at them and figure them out yourself in your head, they mean nothing to you, okay? So I want you to look over the proofs and see can you do it out yourself, okay? So I've given you page 307, I can't remember, it was 2022 and 24. Okay, so I've given you this now, and girls, as I say, look over the proofs, because I'm going to wreck your head with proofs all this week, so I'm going to bombard you with different ones tomorrow. So unless you get these ones straight in your head, right, you will be driven demented, right? So look over the proofs tomorrow, or look over the proofs and see can you do them out yourselves, okay? Right, you'll be happy to know I'm done now, right? Also, I recorded this, so I'll put it